So this is a sapling question. We have essentially here 5 different molecules, 5 different functional groups. So the first one, what kind of functional group is that? An al. That's a aldehyde. Aldehyde. An O8. I know what that is. That's a ester. One bromopentane is just an alkyl halide. So these are not the right products, right? I'm just drawing out basic examples. Hex means how many carbons? 6. Very good. Hexanol would just be a alcohol. And hexane nitrile, of course, would be a nitrile. Good. So first thing you need to just recognize that. You just need to know what a hexanal is, right? You know, what's an aldehyde or what's an ester, what's the nomenclature, that basic nomenclature. And then they ask you to find reagents that can convert each of these star materials into a carboxylic acid. So now it's just kind of a base way to figure out what does each thing do. So let's take a second to think about that. All right, so we need to turn all of these into a carboxylic acid, and we need to know the reagents to do so, right? So whatever we need to do to turn these carboxylic acids. So an aldehyde, I know at least 2 reagents you can use to get an aldehyde to turn into a carboxylic acid. One of them is, actually there's maybe more than that even, that we've learned about. Aldehydes, you could use chromium. I think you use KMNO4. And you could even use Ag2O. So there's at least 3 ways to turn an aldehyde into a carboxylic acid. What about an ester? How do you turn an ester into a carboxylic acid? 2 ways to do that too. NaOH. So don't go crazy here. There's one way is NaOH, which is a acidic or basic way. That's a basic way. So there's a basic way to do it. What's the acidic way going to be? H plus and water. And I think we went over something similar to those kind of mechanisms that turn esters, any ester, right? One way is with base, NaOH, and water probably. And the other way is H plus and water. Sometimes you need to heat these up too, but acidic and basic. So it turns an ester back into a carboxylic acid. What if you wanted to turn an alkyl halide into a carboxylic acid? What would you need to do? Make it Grignard? Right? You could do there's 2 ways to do this too, right? Which would this be? This would be the make the Grignard and then CO2. That's right. And step 2 is CO2. Good. And then usually you have to do a step 3, like H plus, to get it protonated, whatever. What's another way to turn an alkyl halide into a Grignard? The other way to add 1 carbon with nitrile, right? So that'd be the CN minus. And then you need to turn in the carboxylic acid. What do you need to do? How do you turn a nitrile into a carboxylic acid? H3O plus would do it, or H plus and water. And actually, nitriles will turn into carboxylic acids with H3O plus and water, or that's an acidic way. Guess what? I think we did this, maybe. But also, NaOH will turn nitriles into carboxylic acids too. I want you to do the acidic way. Write out the basic way, see if you can do it. Okay. So I'll show the acidic mechanism to turn a nitrile into a carboxylic acid you've seen before. I'll redraw the basic one when we get, you can imagine when we get there for this, the nitrile. There's 2 ways to turn a nitrile into a carboxylic acid. H2O plus, NaOH. And I'll show the mechanism for that. But before we get there, how do you turn an alcohol into a carboxylic acid? What are 2 ways to do that? chromium and KMnO4. One of those two would work. Ag silver 2 oxide only works on aldehydes, actually, so it's selected just for aldehydes. So chromium or KMnO4 will do it. If you wanted to stop at the aldehyde, you could use PCC or DMP. So be thinking of all that kind of stuff. All right. How do I turn a nitrile into a carboxylic acid under basic conditions? So the first step is going to be addition, right? Because we're in basic conditions. All right. Oh, let's see. We could do a proton transfer. There's usually some water floating around in these reactions. So we regenerate our OH minus. So it's a deprotonation. You can think of it as a proton transfer if you wanted to. Remember, the end goal is we're going to lose NH2 minus or NH3. So the same end goal as before with acidic conditions. We're just, right, different charges. So this can react here. Right, again, remember, we have to add 2 oxygens. We're turning this into a carboxylic acid. So addition step, tetrahedral intermediate. Proton transfer. Then we'll do an elimination. And this will be a tough one, but because N8, you can imagine N2 minus is not exactly a great, NH2 minus is not a great leaving group. But if we ever do form any of this, what's going to happen right away? It's going to immediately react with the carboxylic acid. So you're going to make NH3. NH3 is a gas. We're done. So we actually don't make, right, in the basic conditions, what you make is the carboxylate itself. And NH3, right? Because you start with a negative charge, you got to end with a negative charge, overall negative charge. So that's why usually in basic conditions you do the nucleophilic part first, and then the second step's always acidic, right? If you've seen that, remember we've seen that? That's people get confused. It's like step 1, step 2. It's like, wait, there's acid there. It's acidic conditions. It's like, no, that's the second step, right? The reason why you add acid is because now, right, that protonates this, and that makes it soluble in an organic solvent. So yes, you can do some organic chemistry with it, right? Because it's super polar. So that's the basic conditions way to turn a nitrile into a carboxylic acid.